Good evening and welcome to the Ross Agriculture Community Meeting. Tonight's open discussion and project review. We may have a couple different team reports and then a couple ongoing projects. I don't know who wants to go first. Bill, how are you doing on that? Do you want to cover the minimum viable product and we can jump on with what pieces we have?
I don't have anything new or additional to report since the last time. I haven't actually worked on anything myself over the past week. So probably wouldn't be a good use of time.
That move base flex, I think, is what it will do what we want it to do.
Okay.
So I spent a little bit of time playing around with move base, trying to figure out how do you send a generated predefined made path into move base, and you actually can't. The communication between the global planner and the local planner is internal, but the move base flex exposes that in an action. So it gives you the option of sending in a goal, or you can just send it the full path.
Okay, so it'll allow you to transmit in a sense, a collection, an ordered collection of waypoints.
Yes.
And it'll pursue those waypoints individually instead of always using the most recent waypoint it has received.
Yes.
Okay.
Yeah. So I was supposed to, when you do the generated, so a path in ROS is an array of poses.
Yep.
And if you want to do like the generated path with all of those points, I need to put that into a YAML file as poses. So I'll change that around. Instead of just having the individual X, Y, and YA, I'll change those into the YAML file, the correct format, and then we can read those in.
Okay.
And then you can pass the move base flex the path, and then it will drive there.
Okay, that makes sense.
I have a quick demo if you want to see it. Just
I do.
Who likes demos? This is just a quick pass. I don't really need to understand it more and learn more about it. And I'm still learning how to use the TEB. I've been using the TEB planner as our kind of the controller. And there's a lot of parameters to tune in there, and that takes some time. So this is the generated path. This is in RViz, and this is our little tractor. The red lines are generated path, and then the green line, which is a little bit hard to see, is TEB with the local plan. Now, it's just taking in these waypoints and then trying to follow it. The one thing I noticed on these turns, the vehicle actually slowed down. So there are some like vehicle kinematic parameters on weight and different factors. So that may be a nice thing to have, or a nice feature. So I'd like to test this on a real vehicle, this exact same path, and then see how the lawn tractor can travel. The simulator's overshooting those turns. I didn't spend too much time trying to calibrate the simulator. I just kind of get it roughly going so I understand how it works, and then I'll calibrate the real vehicle. What do you think?
It seems to do the job.
Yep, looks nice.
Yep, that looks good. It's internally also using the accent server, right?
Yes.
So there's a bit of lag, but I didn't see that that's that bad, you know?
Yeah, I don't know how the real vehicle will compare with the simulator, so that'll need to collect that data.
What's the refresh rate?
The simulator's running close to 30 frames per second.
Okay.
It could have been my recording on my computer, and that's why you get those little skips. So that's move base flex with the TEB local planner, passing in a generated path. There's a lot of configuration parameters with the move base stack that I'm not too familiar with, and also the TEB planner has a lot of tuning parameters that I'm not familiar with. Always one more thing to learn.
The turning radius, I think if we increase that a little bit, I think it would take really nice turns, like on the path itself.
On the generated path, widen those out. Yeah.
It looks like it. Otherwise, you know, you probably may have to tune the wheelbase.
Yeah. And it was cutting those corners too, but I don't know. I mean, I'd like to compare it with the real vehicle and then kind of see how it differs between the simulator and the real vehicle.
Yep. I'm also trying to use the same path, the file, and then what I'm trying to do is right now, what I'm working on and a little bit stuck is the on the simulation side, that how it talks to, you know, like let's say for example I have the either twist messages or maybe even Ackerman, but I needed to find the controller on the simulation side which could respond to it, so that it can actually follow the track, which is I'm working on that pure pursuit. So, you know, once I actually kind of fill that gap, it should be able to follow the path, at least for now. And then I'm just not publishing the Ackerman frame at this point, but I will publish the like a carrot frame, which is sort of where it looks to, like some look ahead distance ahead. So we're going to be publish that the frame, and then that will be on the transform would be available onto the TF frame, sorry, on the TF tree, so that if any points that coming in, so be able to transform that from the carrot frame to the base link. So it means that we can always have the look ahead point transformed into the base link, so that we can apply the velocity, the linear x, and then also actually should be able to apply the angular z onto the Ackerman. So I think now I'm just getting in between. And what I'm using right now, what the last question that you had onto this minimal viable product is to get the path through the service call. And I think it's a good idea because what I'm doing right now is I'm reading the file. So I think going forward, in the future, we just wanted to convert that into a service call. So every time, when you stop it, every time when you run it again, it will always fetch the new file. And then I think that's probably a good thing to do. That's what I'm at. Actually, I find a very little time last week, so I couldn't work much on it. But I think there's some progress.
Okay, I was looking at the TED planner, and it is outputting. There's some feedback on your speaker, Sam, or your mic, but on the TED planner, there's a function that allows it to change to do angles. Instead of angular velocity, it will do angles. So it's sending out a twist message over command velocity or CMD-vel. So, but it's range bound between minus 30 and 30. So if that helps, if you send an angle from minus 30 to 30, or you can send, so the stage simulator is listening for a command velocity message. But if you want to, we can have another node listen to that command velocity message and then output the Ackerman messages. There's a little bit of feedback on Wilbert, your speakers there.
Yeah, so also what I'm actually keeping the angles limited to plus or minus 24 degrees. So my turning, I'm clipping anything what's more than or less than like about 48 or 50 degrees, like from the center. So I think there's the NumPy has actually the inbuilt function called clip. And I think I'm using that just to maintain if my turning at any point would count more than certain degrees, then it would just put it back to maximum turning angle, which is I'm keeping it like right now about 24, 25 degrees.
Perfect.
Yep.
Yep. Yeah, we had a question a little bit about that because on the joystick command, the joystick, if you're teleoping, it goes from -1 to 1. And so we kind of did a map to the full lock left, full lock right on the robot. But then if we do the autonomous planning, it's only going to send us an angle of 30. So we need to kind of get those equal. So when you're teleoping it and when you are driving it, it can do the full range of steering and velocity.
Yeah. And then that pretty much can happen like in the beginning where you got your point somewhere and then you're starting your vehicle and then the first vector and the path vector versus the vehicle vector. And then you find that angle is pretty much actually more than certain degrees. Your vehicles, try and actually make the turn with the full degree. So you got to click that and then you refresh every like about 30, 40, 50 hertz, whatever it is. So you click that and as soon as you hit the second one, you will click the angle again. So it will slowly turn like at the rate of the 50 hertz or 40 hertz. It slowly turns and get to the point where the very first time where it goes there. But then once it's on the path, I guess there's not a lot of problem because I think it would not, your path vector versus your vehicle vector would be like maybe plus or minus 5 to 10 degrees at the most. Okay. So that's not a big of a deal then. It will always try and correct itself when it just sees the angles like within certain degrees.
It's nice. It'll be smooth. Um, so when you're working on the safety node,
Yes. Yeah, I had some progress, I think. I, I mean, I'll let you guys decide if it was progress. Uh, okay, let's see. I'm going to share my screen here in a minute.
okay.
Hmm, let's start with this one. Okay. Can you see it?
Yes,
Uh, do you also see the white blocks or
Ye-
no?
yes, the white blocks.
Yeah, okay. That was okay. Now it's better. So this is what I came up with. It's pub, publisher and subscriber. So it publishes yes, it publishes CMD well safety message, and it subscribes to the scan messages. On the simulation, we are publishing over scan. This is a laser scan message. It and we can configure our Arduino or the teensy. It's a teensy, so we can configure our teensy to publish over /scan, and the message type is sensor message laser scan. Uh, Here, I mean, this is unnecessary, but I just like it to stop, so I am publishing zeros. So it's a simple reader. It reads on scan, and then there's a parameter we can change. The default is 2.5 meters. So, so yeah, and we're just publishing. Um, Stop share. So what I did was I made these changes, and then I have a terminal going on here. Uh, okay. Just give me a second here, please. Right. So this is the simulation. Um, okay. Oh, yeah. So I put in that, and so I'm just gonna keep. I'm gonna wait. Okay. I think it's stuck now. Oh.
Live demo.
Yeah. Let's do it again. I'm gonna relaunch it. That was my fault. Also, my computer just stopped responding, so I gave a random message or a navgo there. Let's see. Uh, okay. So I'm just gonna keep it close here. I'm gonna preempt that one. So now there's two of the sensors are publishing below threshold. This is less than 2.5 meters. So what we see here is, oops. Oh wait, it's not less than 2.5 meters. Let me give another 2D go there. Okay. So, wait, I need to share the screen. And I'm subscribed here to the CMD Web Mux safety node or safety topic. So it keeps on publishing zeros here when on the simulation. I don't know how to share multiple screens at once, so bear with me here. But yeah, it keeps publishing. Wait, I think I can if I. Okay. So, uh, okay, and then it stops publishing. Wait, that's estimate. It stops publishing when it's not less than the threshold. So the idea is for this node to just kick in whenever the the tractor picks up anything. And in terms of integration, uh, I have on this side, you can see the screen with
Yes.
studio code. Okay. I think not here. Oh, I had it right there. Sorry. Okay. Yeah. So this is the CMD Mux node, and what this one does is it subscribes to uh, all the Mux CMD Mux nodes or topics, and then it publishes CMD. And ideally, the simulation should be listening to the CMD topic. So this one does that. However, I'm still trying to figure out how the priority works on this one, because until now there were just two nodes, these two. And what it did was, so it says on auto data and then on twist. On twist is the manual one, and then on auto data is the, it's the CMD the planner generates. So, and then we're just passing to angular velocity and then linear velocity. So there is that. On here I have that, but I doubt that, I'm trying to understand what this node is doing, and I feel like it's something, so how you prioritize these nodes is using timeouts, but I'm not so sure about that, so I'm learning more about it. But how essentially how it should work is it should be listening to scan messages and oops, not this one, scan messages, and then it would publish 0 when you don't have, or when you see anything less than threshold. So yeah, that's the idea. And then this node should only publish, or should be passing along that, and the safety one should be on second priority. I think teleop should have the most priority. So if you're trying to, so if the vehicle is stuck when on an autonomous mission, it would essentially it would stop if there's an obstacle, but then you can choose to drive around the obstacle, or you wait for the obstacle to move. But it's manual so on twist or on teleop, it should function. So it shouldn't. So the teleop has more priority than safety, but the move base has less priority than safety. Is how I think of how I think it should work. Not there yet, but I'm trying to understand how this works. I don't want to change this essentially, because it's a tested system and it works. It's from here, so that's where I'm at. The safety node works. So next is to use these. Also, safety has a parameter, so we can change stuff, and we can change stuff on launch. So that's nice. But yeah, if you have more suggestions on this, I would appreciate that. And the next one would be, or the next thing on my list would be to actually have working diagnostics. So once I have this working, I will have something to diagnose. Other than that, there's no need for diagnostics. So uh, for now, I'm working on this, and then later on, I'll work on something else on the diagnostics, if not anything else. So yeah, that's my progress.
That's excellent, Sohin. You brought up some good points. There's a little bit of feedback on your speakers. I don't know if you can turn the volume down on your speakers on your laptop or something. You brought up some good points about how that safety node works, and then the prioritization. So if your vehicle is driving autonomously and it comes to a wall, and then the safety system takes over and shuts the velocity off, how do you back the vehicle up? So if you give teleop preference or a higher priority, then you can take manual control of it and then back it up. But it may be a nice feature to, it's kind of like guided teleop, where the sensor still would stop you from manually running. How to set up that safety controller. Does anyone have any experience with that, or have any ideas of how to prioritize those?
So if you're running with the action server, you have to preempt, and then that's one of the options. But if you're muxing it, it means that if you have multiple sources of CMD well, what you're essentially doing is making the CMD well your linear x and the angular y to the 0 when you see the obstacle. When you say priority-wise, what should take over is the safety ones. That comes first. So it means that as soon as you detect something, you want it to make the velocity, like a linear x and the angular z, 0 right away, so that you don't move. But if you're using the action server, then you can preempt the current goal, and you say, okay, stop there. So that will be a preemptive action for the action servers if you're using that. If not, then you would just straight go to the linear x and the angular z, and then say, okay, that's 0, stop it, or stop it within the stopping distance, and then you can just either go to the 0 slowly, or you can, if you're already slow, then you can actually slow down within certain distance, so that you don't hit the obstacle.
That's a good point, Sam. I thought of adding or putting the safety node or to the topmost priority. So the goal of this particular software was to just see and stop. I didn't think of putting in an action server for that matter, because it was just an overkill for the function and the purpose. So that's why that's why going with the mux, because it's a really simple interface. But as Matt suggested, of having so also, yeah. So when the system, if we put the safety node to the topmost priority, saying that if it sees anything, it would keep publishing zeros, and that would have the most topmost priority, our system would be in a deadlock. We'll have to manually, drag it out if we want to. And that's exactly why I think having more control in terms of teleop is a better option. But I like the idea of having a suggested or a guided teleop, and I think that's where the diagnostics would come into play. So we will still have total control over the system, even if there's an obstacle below threshold distance. But the system would essentially scream at you saying there's an obstacle, so don't be a fool, or something like that. I don't know. But yeah, I think that's how both of these system or both of these different I don't want to say systems because they're not systems, but they're both of these functions come in into play together. Uh, the safety would just stop it on autonomous vision, but it would still give you control over your machine if there's anything out there. Like, it doesn't matter if you want to run something over, you have the right to run it over because you're in control. I think that's how it should be. And on the other hand, the system will tell you if you're really close to something. So I think that would end up with us having the best of both worlds, I guess. So that's how I think it should be. But obviously, inputs are welcome. Thanks, Matt and Sam, for your inputs. They were nice.
I totally agree. Where you can actually take over if you wanted to do it through the teleop. I think what you can explore is, like, we're talking about the state machine that actually we may be able to deploy. So at any point in time, you're in one state. So if you have all of these mugs within the states, you can constantly looking for the obstacle, right? So you're like polling it. You're taking a pulse, like every 10 hertz or 20 hertz or whatever, and then you're into the one state and you're running with that. As soon as you see the obstacle, what are you going to do is the other state should come in and say, okay, well, we've got to stop. So you're getting into the other state actually. And I think you can pretty much deploy the states over here. I mean, I think it has a good use case probably over here too. So you can look into that direction. If you can deploy the state machines. Also, the recovery behavior, where you can do it, but it will only be possible if you're using certain algorithm where you try and do the where you go back out and then you actually do the the automatic the path planning again, which is like part of your local planning. So if you do that, yes. Also, the recovery is just possible within that state, where you're just backing out, you're stopping it. And also, it's possible to take over through the teleop at that point. So I think there are like 2 or 3 options at this point, because we're not using the automatic, the path or the local planner or automatic path generation. The recovery behavior will be hard, but I think, like you said, the teleop I think would be the good option. So teleop should kick in at that point, where you can transition into the other state when you actually start operating the probably the teleop, and then it would just actually take it out from the obstacle, and then from that point onwards, you probably have to feed the path again to start the tractor, so that just probably be on the path again. And then in that case, it's just a simple respawning of the node so that it can actually read the file again, or you have to actually input the file again from that point. So that it can start actually from that point and then going on to the path kind of onwards to the end. It's that the kind of a thought process that, what do you think that should happen?
Yeah, that's just a lot to implement. I get what you're trying to get there. I think this video explains exactly the kind of behavior you're expecting. This is from Clearpath, and they're demonstrating their waypoint navigation. About the recovery behaviors, the safety node should kick in when the threshold is too low. And not so I know that Matt has a step planner parameter where it would try to plan a path if the range is below a certain threshold. So it would try to plan a path around it. But if that's too late, then this is what should kick in. This is essentially if someone just walks right in front of it, it would stop. I think that's the use case here. But yeah, I would love to see that happen. I don't think I can implement a lot of that in terms of state machines and just. I mean, if we think about it, there are three states on here of the system. One of the states is the autonomous driving. The other state is teleop, and the third state is an obstacle being detected. So I think those are the three states that we're looking on here, and that's how we're prioritizing. So if there's an obstacle and you're in autonomous mode, you stop. If there's an obstacle and you're in teleop, you don't. You keep passing on the messages that you get from teleop, even that if that means that you need to run into the obstacle. And the third state would be I don't think there's the third state would be no obstacle, so you keep going, no obstacle, and you're on an autonomous path, so you keep going. So that's the three states that we're trying to approach here. So but yeah, it would be cool to have the resume path function. So once you're on a path, and if it sees an obstacle, it would just stop, and then you get to move the vehicle, or you have the obstacle move, and then it would just resume going on. So it would just resume from there. So yeah, and
Yeah,
also,
that's kind of a thought process. It's just just have to play around it. This is because I've done the one of the other like a move last week, and then that's where they're like use the states very extensively. But I don't think that we have to go into that detail that far. I think we have only 2 or 3 states, and actually we can apply that very efficiently in this case without getting into some of the prioritizing things and stuff, and then you just transition from one to the other. And I think it's just pretty easy to do it and deploy the state machines if you can. Like even if we can just start with 2, where the one's the autonomous and the one's the manual, and then we can add just for the safety, and then you just go switch in between. And like I said, at the time, you have to be only in one state. So I think it's probably safe enough, to deploy that.
yeah, that's the plan.
Cool.
Then we got a pathway to minimum viable product 2.0.
No, it'll be 0.3.0.
Okay. Baby steps.
Also, there is one thing, since you mentioned recovery behaviors. Say you're on an autonomous mission and you see an obstacle, it's gonna keep. So in this case, the planner is gonna keep publishing until it sees something. Well, it shouldn't though. Yeah, it's gonna try and plan a path around the obstacle in this case. But then on the other hand, your vehicle is gonna stop moving. So it's gonna ultimately the planner would end up saying, "Hey, it would." So the move base would go into recovery behaviors because the vehicle is not moving at all. So it's gonna try and do some recovery behaviors, and then it's gonna say, "Hey, I give up." So at that point, the mission would end, and you'll have to restart the mission. So that's a drawback that I just thought of right now.
That is correct. And also for us, that is not possible just because you see that you only have a local planning possible when you're running on the SLAM with the autonomous, the path planning, which is a part of your local planner, which we don't. So that is not going to be possible, at least for time being, unless we come up with some really intelligent solution about it. Because our global plan is the plan, and right now, if we are actually fitting the path, there's no way that we can actually do the local planning because our path is like kind of predetermined. We don't use any SLAM-based algorithms. We don't have any intelligent, the path planners kicking in at that point if we are getting to the recovery behavior. So that's kind of a thing that is just probably not possible at this point. At least I don't see it just happening. But what you said, like the stop on. If you see some, the obstacles, tell you of taking over, you can just manually actually taking control over it, and then you can fitting in the path again, the rest of the path. All those things is actually possible. That's what I'm thinking at this point. That it can be sophisticated to the point, but it cannot go into the recovery behavior and then actually sort of figuring out its own local. The path around the obstacle, that is not going to be possible. So that's what I think right now.
It would be fun to test it out in the simulator, and then we can see how it works and maybe come up with some ideas of how we want it to work.
Yep.
Awesome. Thanks, Sohin, for making that. It's pretty cool.
Yeah, thanks, sir. I think it's just to look at the obstacle, and then where you actually showing that into the RVs. I think it's just a lot of progress actually.
I try.
We got Kalyan's on tonight. You want to give us a report from the perception team?
Hi, everyone. Yeah, so we've been working on coming up with a website where people could do training of models. And let me share my screen, what we have. Can y'all see my screen now?
Yes.
Cool. So I know in the past, maybe some of you guys, when you were there, I showed you we were able to get into the Cloud Riser and train our models using Python script here. So we were using Google Colab to train our models and do beat detection. What we wanted to do was we wanted to make it easier for everybody to come and train their models. So so what I've been playing with was, okay. So if you notice that now we created, this is like a beginning of what we want to do. So you can see that this one, ideally we would have a bead finder here where you could upload your picture, and then you, when you say predict, it will automatically detect the location of the bead on this website. But before we do that, we want to do baby steps, and this was part of that. Where if you come here to this website and say, or something like that, then it would come and predict saying that it's not a spam, right? And then you might say, then it says spam because obviously I don't want to suck. So, so what I've been playing last couple of weeks is that we now what we did was we took some of the Python applications. So let's say this was our Python application, which we wrote to do prediction of the beads. Now we are hosting that on a Google Cloud here. And then from there, we are also hosting a website so that every time a user enters in a input file or input text, and then when they say predict, it will call the Python node on the Google Cloud, and then it will return the prediction here. And once the prediction is returned back, we render that again on here. So in this case, we are rendering this in a different color, right? So we would render that back and do that. So the idea would be, right now it's only prediction we are working on, but at some point of time we want to have so this might have a couple of different pages. So you might have a predict page at some point, and then you might have a train page. And then once you come to the train page, you'll be able to upload all your files. And the goal is to allow you to select different types of models, YOLO, V3, SSD, any type of model you might have, and then say train the model. And after that, if you say download, you should be able to download the Python code for that model and also the weights which are associated with the model. So we're making progress. We're making slowly but steadily. So the next step for us is to take the weed detector one, the Python code, and then embed that into web applications so that people can start using it for prediction. And then afterwards, maybe in a couple of weeks after that, we might start thinking about training, giving an option for people to train on the website. So the idea would be here is that you don't have to know all the nuts and bolts of deep learning. You just upload the data here and then say train the model. It would create the model, and then you can download a ROS node at that point of time and plug that into your application, and would run that on the robot. So that's where we are. So yeah, we'll probably do some more changes to this website in the next couple of weeks.
Cleaning up the pipeline for training and predicting weeds.
Yep, yeah. So we want to clean it up and then make it much more reusable for other people to use in their applications. Yeah. And if we get successful with this, then the following AI projects or deep learning projects should have similar template in terms of loading. So the first one is going to take a while to build up the process, but once we get the process nailed down, the subsequent projects should we should be able to build much faster.
It's awesome.
So is your
Alan.
plan, yeah, is your plan that you would have people upload individual pictures? So how many of each weed to train the different classes?
So that's a good question. So we're just starting to think about that. I think for prediction, we'll allow people to upload one image, but for training, the idea would be people would load their data onto a website or a GitHub location, and they would paste the location of the GitHub page here and say train on the data. And then we would give some level of templates as how to upload the data. So for example, for object detection, we might say, here's the folder structure for your data, and then here's how the annotation file should look like. And then at that point of time, it will, as soon as somebody gives the link to that location, we'll download the data from there, train the model, and then we'll allow other people to download the model and the weights for that one. Does it sound reasonable, or?
Yeah, there are a number of different scenarios, so it sounds really fun. And I don't know, we probably need like 3 hours to talk through all the options. So I won't go into it too much, but yeah, we've thought a lot about how that might work. So pinpointing, for me, pinpointing a spot on the image is going to be key. So if I have a weed and I have a base of a weed, I want to be right at the base.
Right.
Right. So I don't want to just be in the general vicinity. So I need to be that precise with my object detection, if you will.
Sure.
I spent some time with mechanical work, the crowdsourcing option, getting some labeled data that way. But I think with some of the visual techniques that have been developed recently, you could probably do a lot better with machine learning neural networks and stuff like that, some adversarial type stuff, rather than, you might still need some crowdsourcing. But
Well, there are a lot of tools for people to go and annotate their images. Our idea is not to replace that. The idea would be people would still go there, annotate their images, and then once they're done, they would bring that annotated file in the images,
okay.
and then they would just give us the link to that so that we can go and train the models.
Yeah.
Well, right now, a lot of people do coding for it, which is fine, but the learning curve is a little bit steep, and also people need to understand all the dependencies to install and get the system up and running. The idea with this one would be they don't have to deal with any of that. Only if they want like the best in class performance, then they would go and tune their models. Great. If you have any, if you guys have any suggestions, or if you guys want to post any comments on the perception channel, and we want to, somebody else wants to take some more work on this, I would love to.
Kalyan, are you planning to expose this APIs so that if I wanted to call directly from my program, I should be able to actually upload the image and get the results?
I think I got your intention, Sam, but I just want to make sure I capture it properly. When you say program, and which program are we talking about?
So if it's a part of my node, I have the image and wanted to upload it and get the results back.
Oh, okay. So like a remote, I haven't thought about that use case. It might be too slow, right? Typically for people to send images from the robot to a cloud server and then get back.
Yeah.
That would be pretty slow, right? That being said, the initial intention was for prediction and all, just as a test platform. I know that for mobile robotics, that might not be the option, but I know people who do robotics in industrial scenario. For them, that's okay. They can still send it to a cloud. They can and they can get the results of that one, right? The idea would be not that one. I think that the reason we want to enable prediction and all in the beginning is for people to test and understand. So we might have a pre-canned set of weights and models for people to upload their images and test them out just for fun. But the ideal user story would be people would bring this folder full of images and a file which shows all the annotated images, and then they would just give us a link to that so that we can train all that data. And then nobody would have to write a Python code for object detection on the robot. It would automatically generate some code also for people to download, and also it will give some weights for your specific application. So those two together would be placed on the robot, and it would start doing object detection and obstacle avoidance based on that.
Okay.
So the input would be the files, and the output would be some Python code and weights, which would go for the neural network.
Okay, cool. Yeah. Well, I saw that you're using the Flask behind the scenes. So.
Yep.
Right now, I've been playing with the SQL Alchemy and the Flask a little bit too. Mm-hmm. So it's just good to see that.
Yeah, by no means I'm like the web developer or web person here. I know till the Flask and the deep learning model, but front end, we just want to keep it very simple. Like at some point, if we have more web developers in the group, then we'll have like a fancy GUI and all that.
Yeah, well, I think right at this point, HTML, CSS would do the job. You don't need to go into any more detail.
That's all we want to do. Well, I think we might need some JavaScript or something like that. So I haven't completely thought about what I want. So let's say we're training the model, right? And the training of the model, if it takes, I'm going to take an extreme example. Let's say it takes 1 hour, right?
Okay.
In that case, people want to see progress of the training, right? So one of the thought would be we show them progress, like how the accuracy is improving over time. And then we might allow the user to type in their phone number, email address, and then whenever the training is done, they'll get a notification saying that, hey, training is done. Now you can go and download the images. So we don't expect people to sit down and watch the training for 1 hour or 2 hours, right? So
Oh, definitely, yeah. Yeah, that makes sense because that's the longer session, right? So.
Right. So it would be like asynchronous and people can do their work, don't have to watch all that. And the idea of having the web page is nice is that now people can anywhere in the world, they can log on to this website and then see the progress of the training on this website, right? So ideally, you don't want to see that web page for 1 hour, but maybe you do want to see it after 15 minutes. You still will have access to it.
Yeah, I agree. Going forward, yeah, I mean, you can include those little more fancy things, but I think right now,
Yep.
probably we're the one who's going to upload the images and stuff, right? So, so.
Yep. Baby steps. we just want to upload the image and predict, but we do have some big plans on what we want to do with that website.
Yeah.
It's neat. Thanks, Brian.
Cool. Yep. Thanks, Kalia.
Will, how's farming going?
Going well. Just actually in the barn, I had a cow calf, so kind of on the phone, but just listening in to you guys. But it's going good.
Awesome. See ya.
See ya.
Jeff, closing thoughts?
I've been doing a couple things. Here's that IMU sensor like Matt's been playing with, hooked up to Raspberry Pi. I've got one of the ST Micro ones and one of the Invensys 9250 sensors, and that's what it's doing on the screen, and it's pretty stable. And then when you move it, it does that, and just all the usual stuff. And then I was saying last time, I was telling one of the groups that I was working on my mini tractor and that the battery fits down in the frame. So there's what it looks like when you put the battery in. So it's a 35 amp hour battery stuck down in there. Nice. And right now I've got the antenna just stuck on the front because that was a convenient open metal spot to put it. And then eventually the antenna will go back here up over the back axle somewhere. And other things, I broke down today and bought a second one of those U-Blocks receivers. So if that ever shows up, I'll have a second one of those. And as I was mentioning I think it was on the lawn tractor group, those Super Servo 200s, I think, are discontinued now because I went through 3 different places in China and they kept canceling my orders. One guy tried to offer me the Servo 300, and I said, well, if I get it for the same price, I'll take that. And then he canceled my orders. So I think I'll just have to wait till this settles down before I decide to order any more of those. I can't remember if I was doing anything else this week, so that's kind of where I'm at.
That's a lot. That's interesting that they stopped selling those 200.
Well, I assume it's because I looked at the specs. I thought, well, I didn't want a 300 because it'd be slower than the 200 because I assumed it just had a different gear ratio. But according to all their numbers, they say it's just as fast, but it has 50% more torque. So I don't know if that's really true or not. It says it has the same motor in it. But again, everybody's copy and paste these specs. So I don't know. If you still look at Alibaba, they still say they're selling them there. And there's still lots of auctions on eBay for them, but you order it and then you don't get them. So that's just the way that's going.
It's been working pretty well for throttle control on the lawn tractor. So I don't know how long it will last, but so far it's been going well. transmission control instead of throttle, but forward and reverse. Great. Well, it's a lot of stuff going on. Thanks for being here tonight. It's great seeing everybody. Hope you guys have a productive week. We'll see you next week.
Thanks, Matt.
Thanks, Matt.
See you.
All right. Thanks, everyone.